My first film about the reasons for the extinction of mammoths gained over 3 million views. This is more than any other film on this topic, including those in English. Today, I want to make a significant revision to my version from 4 years ago. In other words, I no longer think it was a cosmic catastrophe. Neither an asteroid nor a comet had anything to do with it, as I thought back when I made that film. Any collision between Earth and a cosmic body, even one made of solid nitrogen, such asteroids exist, would heat the atmosphere rather than cool it due to high cosmic speeds and intense friction in the air, often accompanied by an explosion. The likelihood of a comet brushing Earth's atmosphere with its long tail, my initial theory, and taking part of it away beyond Earth's gravity is extremely small. For this to happen, the trajectories of Earth and the comet would have to align for a significant time, even just a few seconds, which is highly improbable. A rapid loss of part of the atmosphere could indeed cause a sharp cooling, especially if it mixed surface air with very cold air from the upper atmosphere. But again, the chances of a comet maintaining prolonged contact with Earth and its atmosphere are incredibly low. Therefore, we need to look for another reason for the significant climate change in Siberia and Alaska, where frozen meat mammoths were discovered. The first complete mammoth with muscle tissue and internal organs, Adam's mammoth, named after the Russian scientist and botanist Mikhail Ivanovich Adams, a member of the Imperial Academy of Sciences who studied it, was discovered in 1799 by a local hunter on the Bykovsky Peninsula in the Lena River Delta. Here's what the 1896 Brockhaus and Ephron Encyclopedic Dictionary says about it. During the examination, needles of coniferous trees and young shoots of deciduous trees were found in the mammoth's stomach and between its teeth, which served as food for this animal. Young shoots of deciduous trees. This indicates the summer months in the Arctic, where this mammoth was found. This means that the sharp cooling happened in the summer, when the initial temperature was above freezing, with young shoots of deciduous trees present. And the undigested summer food in their stomach suggests that the animals died from hypothermia rather quickly, perhaps within an hour, no more. After that, their bodies cooled to sub-zero temperatures, and it was summer. Another factor I overlooked in my first film: mammoths were significantly larger than their modern relatives, elephants, though not all of them. There were also dwarf species of mammoths. But overall, the maximum mass of mammoths far exceeded that of modern African elephants. The last mammoths on Earth were also larger than modern African elephants, but not twice as big, only about 15 to 20% larger. A similar ratio of size is found in other animal remains. The oldest fossil specimens of brown bears, for example, indicate that they weighed up to 1,200 kilograms, which is also twice the size of their modern counterparts. However, the largest brown bears of the late Pleistocene were not twice as large, but only about 30% larger than modern brown bears. The same trend applies to extinct bison. Their maximum mass was about twice that of modern bison, but over time, it also tended to decrease. Horses were also gigantic, twice as large and massive as modern horses. So, we see a clear pattern. All extinct species of mammoth or Pleistocene fauna, with rare exceptions, were larger in mass than their modern relatives. I am deliberately using the word mass here instead of weight. Those who have already seen this film of mine have probably guessed what I'm hinting at. In that film, I explained that Earth periodically expanded not only in volume, but also in mass. I also shared my theory on where the new mass came from. Evidence of Earth's increased mass includes the old Roman 10-month calendar. And by the way, why was it 10 months long, which clearly doesn't match the number of months in a solar year with a 61-day difference? Perhaps the remaining days of the year were not formalized into months. The Roman calendar was primarily a tax and credit tool, where interest, taxes, and other payments were made on the calends, the first day of the month. In the lunar calendar, calends always fell on the new moon. This is where the word calendar comes from. The remaining days of the year were free from calends, meaning free from financial obligations. These leftover days occurred in the winter, long after the harvest had been gathered. It seems that in winter, the Romans had tax holidays during which there were no calends, no taxable days, and consequently, no months in the first Roman calendar for those tax-free days, as they weren't needed. So, the 10-month Roman calendar had an average of 30.4 days per month. Considering that this calendar was lunar, and primarily based on the phases of the moon, it leads to a clear conclusion. The average lunar month of the earliest Roman calendar was nearly a full day longer. Today, the average synodic lunar month, the time from new moon to new moon, is not 30.4 days, but 29.5 days. This means that at some point, Earth's mass increased relatively quickly, pulling the moon into a lower orbit, which consequently became shorter in both distance and time. After that, in the next Roman lunar calendar, the average month length was no longer 30.4 days, but 29.5 days, as it is in the synodic month today. Since then, the duration of the lunar month has remained unchanged. This means that Earth has not expanded or increased in mass since that time. The next Roman calendar was no longer lunar, or more precisely, lunar-solar, but purely solar, detached from the phases of the moon. It was introduced by Pope Julius II, whose secular full name, Gaius Julius Caesar Octavian Augustus, as well as his secular titles of Emperor and Caesar, were taken by 17th century historians and projected into an invented ancient past. According to my reconstruction of Christian history, without its artificial extension by 1,500 years, the last periodic expansion of Earth occurred shortly before Julius Caesar's calendar reform, that is, during the pontificate of Pope Julius I, which was between Pius II, Aeneas, and Paul II. Julius Caesar could not have been the author of a solar calendar, as it is common knowledge, even for school children, that Julius Caesar died on the Ides of March during a full moon, which would have been impossible if Julius Caesar's calendar had been a solar calendar, where the days of the month are no longer tied to the phases of the moon. Could the last mammoths on Earth and the mammoth fauna have lived through this last expansion of our planet, after which the surface gravity of Earth increased? No, they could not, if only because there were no living mammoths left by the 15th century. The 15th century is the century of Julius Caesar, depicted in this painting by his contemporary, the Florentine artist Apollonio di Giovanni. The 15th century, the last century during which Earth actively expanded, was already the age of printing and magnificent realistic painting, which left us no written, printed, or artistic evidence of such a very noticeable animal as mammoths or woolly elephants, if the word mammoth had not yet appeared. There are many depictions of elephants from the 15th century, even if primitive, but there are no depictions of mammoths from that time. Moreover, during the last periodic expansion of Earth, its mass increased by about 6%, judging by the changed length of the lunar month, which is clearly not enough to account for a 30% difference in the mass of mammoth fauna animals and their modern relatives. Thus, we conclude that before the first half of the 15th century, there was another, the penultimate, expansion of Earth with a more significant increase in its mass. And it was this expansion that killed the last mammoths. Even earlier expansions of Earth killed the dinosaurs, which, as scientists believe, would not even have been able to crawl on the surface of modern Earth with its current gravity. By the way, not only did mammoths go extinct in Eurasia and the Americas, but elephants also disappeared. Elephants that were larger than modern ones. Yet, for some reason, no one seems concerned about their extinction. Everyone is only intrigued by the mysterious disappearance of mammoths. Yes, there were wild elephants in Europe, two close relatives of African elephants. They lived at the same time and in the same territories as mammoths and primitive humans, at least according to official accounts. In this photo is a model reconstruction of a European forest elephant, the remains of which were discovered in Germany. The European forest elephant was twice as large as modern African elephants. Over time, their mass decreased, as did the mass of all Pleistocene fauna, due to the increasing gravity of Earth. And here's what's strange. In European caves, primitive people drew mammoths and other animals of the local fauna. But apparently, no one told these primitive people that elephants also lived in Europe alongside mammoths. That's why Europe has many cave drawings of mammoths, but not a single one of elephants. Another oddity with these cave drawings in European caves, mainly in France and Spain, is that they were created in a fairly realistic manner by the hand of an experienced artist. Yet, for some reason, equally realistic depictions of people in these French and Spanish caves are either entirely absent, or, on the rare occasions they are present, people are depicted in a very schematic and simplified manner, while the animals drawn alongside them are rendered quite realistically. It seems that 19th and 20th century artists, the era when these cave drawings were discovered, were good at drawing animals, but didn't know how to realistically depict Paleolithic people. Or perhaps no one told or showed them how. A cave with drawings of animals that are thousands of years old is far more appealing to tourists than just a plain cave, don't you think? Now, regarding the cold. The extreme cold that rapidly froze mammoths and other animals of the mammoth fauna. Where did it come from? And how could it occur during the summer months? The answer to this question needs to be divided into two parts. First, we know that not all mammoths were rapidly frozen in the middle of summer, with undigested young shoots of deciduous trees in their stomachs, but only the most northern ones. Second, the remaining mammoths in more southern latitudes may not have died as quickly, though they also succumbed to cold and starvation due to a drastically altered climate. This is evidenced by Indian elephants, which did not die out along with the Siberian mammoths, their closest relatives. This means that mammoths in the southern part of Siberia could have survived and later gone extinct as a species due to the overall climate change across their entire habitat. In other words, the rapid freezing of some Siberian mammoths cannot be correctly applied to all the last mammoths that lived and died on our planet. Therefore, I propose first to understand the cause of the overall prolonged cooling and glaciation of a significant part of Eurasia and parts of North America, conditions incompatible with the survival of mammoths. Only then can we model the rapid local freezing of mammoths in Siberia and North America. Here is the official map of the last glacial period, and I have one significant question about it. Why does the glacier boundary in the harsher continental Siberian climate lie much farther north than in the milder American climate situated between two oceans? It is obvious that a more symmetrical picture of a large intercontinental Arctic glacier centered around the North Pole would make more sense. And by the way, no complete meat mammoths have been found in Alaska. Only isolated fragments of body parts with some preserved soft tissues showing signs of decomposition. So it is quite possible that the rapid freezing of mammoths was a local and purely Siberian phenomenon. Despite the fact that modern science has drawn a glacial map portraying Siberia as climatically milder than North America. So, what could have caused the significant climate change on Earth, followed by the glaciation of much of Eurasia and North America? There is a concept in climatology known as the volcanism of the Little Ice Age. Scientists have concluded that the main cause of cooling during the Little Ice Age was increased volcanic activity, with large emissions of sulfate aerosols and volcanic ash into the atmosphere, which blocks sunlight from reaching the Earth's surface. An example of such volcanic cooling is the year 1816, known as the Year Without a Summer. This climatic event was preceded by the eruption of Mount Tambora in Indonesia a year earlier. It was the most destructive explosion on Earth in the past 10,000 years. The volcano spewed 100 cubic kilometers, 24 cubic miles of gases, dust, and rock into the atmosphere and the surrounding area. In the spring and summer of 1816, a persistent dry fog was observed in parts of the eastern United States. The fog reddened and dimmed sunlight, such that sunspots were visible to the naked eye. Neither wind nor rainfall dispersed the fog, retrospectively characterized by Clive Oppenheimer as a stratospheric sulfate aerosol veil. In May 1816, frost killed off most crops in the higher elevations of Massachusetts, New Hampshire, Vermont, and upstate New York. On June 6, snow fell in Albany, New York, and Dennisville, Maine. And this was just one volcano in distant Indonesia, whose atmospheric emissions caused sunlight to reflect back into space, leaving Earth without its usual amount of solar warmth for several months. Now imagine how many volcanoes might have become active during Earth's expansion due to increased pressure on the Earth's crust from the mantle, including those near the Arctic Circle, in Kamchatka, Iceland, Alaska, Japan, and Siberia. Take note of the massive scar left by the rupture of the oceanic crust on the floor of the Arctic Ocean. This scar is clear evidence of intense expansion, not the millimeter per year pace suggested by conventional models. Similar scars are found in other oceans. They run along and across mid-ocean ridges, the thinnest areas of Earth's crust, where ruptures were immediately filled with molten basalt from the mantle. These scars are multi-kilometer rifts, up to 50 kilometers wide, resulting from underwater fissure eruptions and their expansion due to the periodic overall expansion of Earth. So, the cause of Earth's significant cooling becomes clear. Its periodic expansion was accompanied by increased volcanic activity, with volcanic emissions into the atmosphere, and this caused the cooling. Now we need to answer the question of what caused the rapid freezing of Siberian mammoths. But first, let us refer to the report of the head of the expedition of the Imperial Academy of Sciences, Otto Fedorovich Herz, to the Berezovka River, for the excavation of a mammoth carcass. The report was presented at the meeting of the Physical and Mathematical Department on February 27, 1902. October 5, 1901. Today we first cut off the skin of the left side and found several ribs, most of which were very well preserved. The stomach, along with its contents, is becoming increasingly visible, while the other organs are destroyed. Let us note that the other organs of the mammoth were destroyed. I continue quoting. After lunch, we removed the left shoulder, on which we left tendons and muscle fibers. The sinewy and fat-streaked meat from under the shoulder is dark red and looks as fresh as strongly frozen beef or horse meat. For a long time, we debated whether to try eating this meat, as it looked very appetizing, but no one dared to put it in their mouth, preferring horse meat instead. The meat of the mammoth, thrown to the dogs, was eaten by them with great appetite. The layer of fat under the skin is 9 centimeters thick. The fat is white, odorless, spongy, porous in texture, and cuts easily. As we can see, the mammoth meat appeared quite fresh, and the dogs ate it eagerly. After removing the last layer of soil from the exposed back, the remains of food and the stomach itself were found. The latter had undergone significant decomposition. Now about the state of the mammoth's blood. In bag number 14, I placed collected particles of blood, resembling potassium permanganate, in small fragments. When softened, these particles leave an easily washable dirty dark red stain. To the touch, they resemble coarse dry sand. This blood, similar to potassium permanganate, is located between the stomach and the sternum, while the blood extracted above the sternum and the left and right humerus had a light clay yellow color and felt like it had turned to lime. In bag number 14, I placed samples of both types of blood, separating them with a layer of cotton. This means that the blood of the Berezovka mammoth also indicates that it was not rapidly frozen at extremely low temperatures, and, like the mammoth's stomach, underwent post-mortem degradation. And here is another very interesting remark. As for the stench initially emanating from the mammoth carcass, it is now far less unbearable than it was during the first 2 days after exposure. However, it is possible that we have grown so accustomed to it that we no longer notice it. The strong putrid smell primarily came from the upper part of the mammoth, which had been gnawed on by wild animals. Here is another excerpt about the strong putrid stench from the Berezovka mammoth. Further excavation revealed the right front leg, which had been bent almost horizontally under the mammoth's belly during its fall. The bristle on this leg had survived only in very small quantities, while the undercoat, yellowish-brown in color, had been preserved in some areas. On the left leg, I also found parts of completely decayed flesh with clearly distinguishable muscle fibers. The stench emanating from this limb was unbearable, forcing us to halt work repeatedly. Even after thorough washing, it was impossible to remove the terrible smell from the skin of our hands, and yet we were forced to perform part of our work with bare hands. The collection of this information indicates, first, that a significant portion of the Berezovka mammoth had undergone putrefaction, even those body parts that were extracted from the permafrost. Second, the strong putrid smell made it impossible for paleontologists to assess the quality of the meat by its odor, which they fed to the dogs. Let me remind you that the fact that the dogs ate this meat does not exclude the possibility of partial putrefaction. Dogs can eat meat with a moderate putrid odor, which is less critical for them than for humans. Thus, one myth about mammoths, their rapid freezing, has been debunked. However, it was still freezing that caused their death. Moreover, it happened in summer. On the same day, the temperature was above zero, and then it suddenly dropped below freezing. Could such rapid freezing happen in our time? Yes, something similar happened in South Dakota. This weather event was called the Cattleman's Blizzard. On October 4 to 5, 2013, western South Dakota was pummeled by one of the worst blizzards in the state's history. Winter Storm Atlas was unexpected and deadly. It began as rain, but then temperatures plummeted and winds began to howl. When the clouds cleared 2 to 4 feet of snow blanketed the Black Hills and surrounding prairie. Ranchers lost cattle, horses, and sheep in the tens of thousands. Beef cows and calves, which hadn't yet developed the heavy coats that see them through the cold winters of the northern plains, were soaked first by freezing rain and then buried in the snow. Tens of thousands of cattle suffocated or froze to death. The cause of the cattle's death was not so much the low temperature, only -1 degree Celsius or 30 degrees Fahrenheit, but rather the combination of strong winds up to 60 miles per hour or 27 meters per second, freezing rain, and a blizzard, which first immobilized the exhausted cattle and then buried them completely, causing them to suffocate. Something similar could have happened to mammoths when they were first drenched by rain, then freezing rain, and finally a blizzard that lasted for several days or even weeks. This event was likely the beginning of the Ice Age, which followed a massive volcanic ash release into the atmosphere. The glaciers of Eurasia and North America preserved mammoth carcasses under thick layers of ice and dense snow for hundreds or perhaps thousands of years, as official science suggests. On this elevation map, I've outlined the approximate range of Arctic mammoths. It is clear that before the glaciation, the climate in these regions was not as harsh as it is today. This could be related to the fact that on a smaller Earth, before its expansion, the temperature gradient between different climate zones was less pronounced than it is now. In simpler terms, the Arctic was closer to the equator, and consequently, the climate in higher latitudes was milder. Only Earth's expansion can explain why the climate in the Arctic zone became more severe. This does not mean that mammoths lived exclusively in the areas marked on the map. They also lived further south, west, and east. But we now need to explain how mammoths ended up frozen with preserved soft tissues in the far north, where today it is utterly impossible for them to survive due to the harsh climate and the scarcity of food resources. Mammoths are associated with another mystery. Their bones are primarily found in Yodoma, which consists of 50 to 90% ice, and the remainder of forest and tundra black soil. In some places, the thickness of Yodoma exceeds 1 kilometer. But where did so much black soil come from around the Arctic Ocean in Siberia and Alaska, covering an area of over 1 million square kilometers, twice the size of France? The well-known American writer and creationist, Dr. Walter Brown, gathered and systematized a wealth of materials related to mammoths. Here's what he wrote about Yodoma, which he simply called muck. Muck is a major geological mystery. It covers 1/7 of the Earth's land surface, all surrounding the Arctic Ocean. Muck occupies treeless, generally flat terrain, with no surrounding mountains from which the muck could have eroded. Russian geologists have drilled through 4,000 feet of this muck without hitting solid rock. Where did so much eroded material come from? What eroded it? Oil prospectors, drilling through Alaskan muck, have brought up an 18-inch long chunk of tree trunk from almost 1,000 feet below the surface. It wasn't petrified, just frozen. The nearest forests are hundreds of miles away. Williams describes similar discoveries in Alaska. Though the ground is frozen for 1,900 feet down from the surface at Prudhoe Bay, everywhere the oil companies drilled around this area, they discovered an ancient tropical forest. It was in frozen state, not in petrified state. It is between 1,100 and 1,700 feet down. There are palm trees, pine trees, and tropical foliage in great profusion. And here's another mystery, closely tied to mammoths. Let me read from the Moscow journal Anti, published in 1859. The northern part of Siberia, now covered only with tundras and low shrubs, contains, at a depth of 100 to 200 feet, numerous trunks of coniferous trees. Opposite the mouth of the Lena River, on New Siberia Island, entire mountains have formed from such trunks. These are the so-called wooden mountains. They rise up to 30 sajan in height, approximately 64 meters, and consist of layers of sand interspersed with coniferous trees. These mountains are probably similar to the enormous rafts that form at the mouths of large rivers from floating timber. But how did floating timber make its way to the New Siberian Islands, located about 300 kilometers from the mainland, and rise to a height of 60 meters above sea level? This place was aptly named Cape Cliff of the Wooden Mountains. In 1955, a scientific expedition was sent to New Siberia Island by the Institute of Arctic Geology. I quote a fragment of the expedition's report. In the deposits of the lower suite of the Wooden Mountains, there are no fewer than 12 to 15 layers of lignite coal, in most cases heavily weathered and crumbled. Almost everywhere in these layers, charred tree trunks are found. The thickness of the layers ranges from 1 to 6 meters. These trunks were not charred by fire or high temperatures, but by specific conditions under which, in the absence of oxygen, wood gradually transforms into coal over time. This is how the cliff of the Wooden Mountains looks today. The black layers are coal, into which numerous tree trunks have transformed. Once again, in the deposits of the lower suite of the Wooden Mountains, there are no fewer than 12 to 15 layers of lignite coal. But what is lignite coal? Lignite is a fossil wood of varying degrees of coalification. The first person to visit the New Siberian Islands on a scientific expedition in 1809 was the Russian explorer of northern Siberia, Matvey Matveevich Gedenstrom. Here is what he wrote in his report. The Wooden Mountains on New Siberia present as inexplicable a mystery as the icy earth layers described earlier. On the southern shore of this island stands a cliff-like mountain composed of horizontal thick layers of sandstone and logs of glossy, resinous wood, layered one above the other to the very top. Climbing the mountain, one frequently encounters coal hardened into stone, resembling pine in appearance. So, as early as 1809, these layers of logs were already in a lignite state, fossilized wood showing varying degrees of coalification. Coalification of wood is a very slow process. This indicates that if this wood bore witness to the Mammoth Catastrophe, we are talking about several hundred or even thousands of years. Thus, the tree trunks on the New Siberian Islands arrived by water. They still regularly wash up there from the mainland, carried into the ocean by rivers. And trees end up in the rivers during the spring ice drift, when river ice, breaking loose, uproots trees growing along the floodplains. But how did the trees end up at an altitude of 60 meters or more above sea level on New Siberia Island? Here, only one explanation comes to mind. During the Ice Age, the height of the Siberian glacier was much higher than sea level, and the glacier itself connected the mainland with the New Siberian Islands. At the final stage of the glacier's melting, Siberian rivers carved their channels into it, carrying timber to the New Siberian Islands, which served as natural barriers, where the wood accumulated at the height of the glacial riverbeds. However, exposed wood in open air does not undergo coalification, as atmospheric oxygen turns it to dust within a few years. This means there was a second stage in the fate of this wood: the delivery of a large amount of Yodoma to the New Siberian Islands to preserve and isolate it from oxygen. The melting glaciers moving toward the ocean from the Siberian highlands acted like a giant bulldozer, collecting forest and tundra soil over a vast area and dragging it to the shores of the Arctic Ocean. Yodoma not only isolated the wood on New Siberia Island from atmospheric oxygen, but also influenced it with its carbon-rich environment containing a high organic content, a necessary condition for initiating the coalification process in the wood. As the massive Siberian glacier melted, its connection to the New Siberian Islands also disappeared, along with the Yodoma, which dissolved into the waters of the Arctic Ocean. But before the glaciers in the ocean fully melted, the New Siberian Islands received not only tree trunks, but also mammoth bones within the Yodoma from the mainland. These were gathered, like the trees, from the vast areas of the Siberian river basins. However, the Yodoma containing mammoths was transported to the islands not by water, but by the moving, melting glacier acting like a bulldozer. No complete mammoth skeletons have been found on the New Siberian Islands, only fragmented parts. This means that mammoths did not die on the islands, but on the mainland. From the mainland, they were carried to the far north, including the New Siberian Islands, by glaciers, which crushed and tore mammoth carcasses and skeletons into pieces during transport. However, some mammoths were luckier, like the Adams mammoth and the Berezovka mammoth. Most of their limbs remained intact, although some bones were fractured due to their glacial transport from their place of death and freezing to their final burial in a layer of Yodoma, a mixture of ice, forest, and tundra soil. Let's once again look at these ruptures in the continental crust, which are clear evidence of Earth's expansion. At first, Earth was the planet of gigantic dinosaurs. Then, the heavier Earth became the planet of elephants and mammoths, whose mass was about twice that of modern elephants. During the last stage of expansion, the maximum weight of elephants stabilized to align with the gravity of modern Earth. But during the penultimate stage of expansion, a global cooling occurred, wiping out all elephants and mammoths except for those in the warmest regions of their habitat, Africa and Indochina. All right, let's assume that Earth's expansion was not the cause of climate change, but rather some cosmic object that rapidly froze the mammoths. But then a natural question arises. If a cosmic object rapidly froze the mammoths, even if it were made entirely of solid nitrogen, why did the mammoths take so long to thaw? Not just years, but at least hundreds or even thousands of years, as official science suggests. Moreover, localized freezing cannot explain global cooling. The glaciation of much of the northern hemisphere around the North Pole, and similar glaciation in the southern hemisphere around Antarctica, was a global climate change on Earth that cannot be explained by any cosmic catastrophe, let alone localized freezing. Unless, of course, the sun suddenly reduced its brightness for some time. But modern science has no evidence of such behavior from the sun. It is officially believed that the sun's influence on global climate change, not its general influence on Earth, but specifically on global change, is negligible compared to volcanic activity. This is because even ordinary clouds reflect sunlight. But when the entire sky, or a significant part of it, is covered with volcanic ash and a volcanic winter sets in for years, elephants and mammoths north of Africa and India went extinct due to extreme cold and food shortages. There is another theory circulating in the blogosphere about the rapid freezing of mammoths, supposedly caused by Earth flipping over, as explained by the effect described by Soviet cosmonaut Johnny Bekov. In my first film about mammoths, I explained why this effect does not apply to Earth primarily because our planet has not yet developed a large bump. Specifically, it would need to be a significant one, as a small bump would not trigger the flipping effect required to form another axis of Earth's rotation for this periodic flip. And by the way, Earth already flips every year due to the tilt of its axis, exposing its northern and southern hemispheres more or less to the sun's rays depending on the season. That is, if this phenomenon of Earth flipping due to the Johnny Bekov effect actually occurred, the planet's overall temperature wouldn't change, and the Ice Age certainly wouldn't have happened because of it. That's all for today. You can find links to my books in the description below. Thank you for your likes, comments, and sharing links to my films on social media. All the best, and see you next time. This was Alexander Tomansky.